How are you, everybody who is watching this video? My name is Olenjolai Yellow singer from beautiful, fantastic country, United Republic of Tanzania. I'm very glad to welcome you into our online school that's called Tanzania Online Ordinary Secondary School in square brackets Olenjolai. Simultaneously, I would like to welcome you into our official YouTube channel that's called the Tanzania Online O-Level Secondary School in square bracket also Olenjolai. Well, in this online training, this is the online ordinary secondary school. It's not a physical school. We have a vision that God has revealed in my mind and even the minds of the other peers who will be working with me now and even in future. And this is the vision that God has revealed to me that we like to be, or we have a responsibility to prepare or incubate or teach some group of students who will be ready to take the classroom instruction in basic mathematics for ordinary level and even basic science, that means in physics, chemistry, biology, agriculture, combined with the knowledge and wisdoms of the Word of God in order to solve real life from our community, okay, in our community ourselves and from the places where these students are come from. Because we used to study in order to solve problems. We don't used to study in order to have certificate. Certificate is just like in confirmation that maybe you have graduated successful or unsuccessful in this level. That means a certificate. Okay, so that the vision that we have in our mind, we are solving a problem, which is a common problem. And even these problems myself I experienced when I have been studying. So today we are in Department of Physics. In this online school, we have 3 departments: physics, chemistry, and chemistry and physics, chemistry, and basic mathematics. Later on, we have some other departments. Keep on praying for us. We like to have a departments of biology, as I guess a departments of additional mathematics, which we're expecting to add up. There's also departments of English language, right? Because it's very interesting. Now, if you'll be learning stuff in English and you know how to learn it. So the subject of the day is physics, and this the physics that we are going to learn is for the Form 2 or for the class 10, right? And hence we are in the main topic is motion in a straight line, and this is session 3. So we are done with session 00, the general introductions of physics for the Form 2. Session 01, we have just the general introductions of motion in a straight line. Session 02, that was still about yes, it was about what? It was about types of motion. Okay, so yeah, this session 3 is types of motion, distance and distance and the displacement. So that's the title. So you can just add types of motion, comma, distance and the displacement. That's the subtitle of the today's session. Well, so I'm very happy to take you again into the next level. Before we begin our sessions, I would like just remind quickly some of the stuff or reference stuff that I've mentioned that you should need in order for you to master this subject of physics for the Form 2, because you know that physics is a little bit crazy. Okay? So I mentioned a reference book, and this reference book is called the Physics Syllabus for Ordinary Secondary Education, Form 1 through Form 4. So that's what you have to make sure that you have it, okay, when we'll be going through, so you know what should you cover in Form 2 or in physics for the Form 2. And this, the good thing, you will use this book from Form 1 to Form 4. In case you need a copy of it, or you need a book, go to the descriptions, click the button show more in this video, you will see how much does it cost. Again, I insisted you to have a textbook, at least one textbook. I mentioned so many. At least if you have this one, Physics Form 1, Form 2 students book, which has been prepared by Tanzania Institute of Education, at least you should have this book beside you when we taking these materials. Okay? And then we have again question and answer. I mentioned that, for example, this one is Physics Form 2 Physics Review. It comprises questions from 2003 to 2019. And solutions. So it's very interesting for students to have. If your parents start watching this video, it means that you have to make sure that you purchase these books for your students. Okay, so you should have an exercise book, and also you should have a pen, you should have a ruler, so that you may go the business. Okay, so we have may do the quick review of what? Of session 02. So session 02, basically, First of all, we define the terms motion. What is motion? I gave you two definitions. Make sure to go through, because the material are still online in our YouTube channel. So make sure to watch that session, session 02 or session 2. Then I mentioned about the basic types of motion. There are 3 basic types of motions. What are they? One of them is oscillatory motions. Mention the rest. If you forgot, make sure to review the video before you continue. And then I explained about the translation. Before even basic types, I've given you 7 examples of motion. 7 examples of motions. Then I explains about, I told you about translation motion, right? And its examples. Translation motion, then its examples, right? Its examples. Then I told you about rotation motion, and also I told you about examples of rotational motion. So examples of rotational motion. Then I left your homework to you, which is this question start with 8 of 7 examples, explain briefly oscillatory motions. And that's why that today I have a guitar. This is acoustic guitar. It's a musical instrument. And the interesting point for this guitar is a type of oscillatory motion. So which I want to demonstrate for you because I love to apply physics in my everyday life. So let us answer. I believe that you did this example, you did this homework before this session. So it's a time for us to do the correction. So the question, according to the nature of the question, first of all, it means we would like to ask ourselves that this is question 5. What is oscillatory motion? That's how I expected you to answer this question. Submit your homework in the comment section so that I'll go through them, or even some other students can review at home. So what is oscillatory motion? Well, there are so many definitions, as I told you, but the simple meanings of this terminology is to and fro movement. Body describing to and fro movement. The body does not describing maybe the rotational or maybe the straight line, the motion straight line. No. So we say that in oscillatory motion, say that the type. So I have this guitar for the demo, for demonstration. It's the type of motion, in which a body, so the type of motion in which a body moves. So for instance, for this guitar, the strings, right, the body moves to and fro, to and fro movement, okay, to and fro, about its mean position, about its mean position, So say that this is the type of motion in which a body moves to and fro motion. To and fro, moves to and fro, about its mean position, That the meanings of what of oscillatory motion. So let me explain. So this is the special type of motion, so basic type of motion, in which a body, right? In which a body moves to and fro about its mean position. What does it mean? How does it mean? For example, suppose that this is the body, this book is a body, right? And this is the mean position. It means that when this body is going to complete its oscillatory motions, is going to stop here, right? And then I move this book in this way, right? So this is to and fro. So suppose that this is to and fro, to and fro. but it's passing through its main position, its resting position. So the speed is decreasing, the speed is decreasing, the speed is decreasing, the speed is decreasing. Then to stop at its main position. Okay? And the meaning of simple oscillatory motion, right? So this oscillatory motions is also oscillatory motion, before we go for examples, is also known as periodic motion. So you can call it periodic motion in some of the books. Okay? Or you can call it simple harmonic motion. Simple harmonic motion. As I told you, there's a topic for this simple harmonic motion. So let me write there at the top. Or it's called the simple harmonic motion. Say simple harmonic motion. So another name for this oscillatory motion is called the simple harmonic. You have to make sure that you keep this material motion until you finish your undergraduate studies. Simple harmonic motion. Simple harmonic motion. This is the topic for the Form 5 physics. So it's also known as periodic motions or simple harmonic motion. So examples. Remember that your syllabus does not allow you to learn the guitar, except that in case of pendulums, also we would like to touch this concept of oscillatory motions a little, because in pendulums is one of the topic that provides questions in practical physics or in physics too. So examples of oscillatory, say oscillatory motion, or in another names is called what? Simple harmonic motions or periodic motion. I asked you to mention 7 examples. Well enough. I'll give you possibly all of them, so a few of them. Okay. The first example was the fundamental example. We say that oscillation of a simple pendulum. Oscillations of a simple pendulum. So we have simple pendulums, but you have a pendulum, you have a bob and you have a pendulum, right? So dance, it means that you take a rotating stance, then you tie the rope or the pendulum, and then you have a bob, then you release a bob at a particular distance, but to the particular distance, and then you release it, so it will be executing simple harmonic motion. Okay? The second example is the one that now have this device. It's called vibrations of strings of the musical instrument. Vibration of the strings. Vibration of the strings, right? Of the strings of the musical instrument, like the guitar, musical instruments. And this musical instrument, for example, guitar, even piano is stringed instruments, but I should not confuse you. So, I may demonstrate to you. So you have to focus on this demonstration, right? So that you can grasp everything that has been prepared, and you have to enjoy the beauty of physics. So I want to adjust the length of this belt so that you may see the strings effectively, in order for you to enjoy the beauty of physics. So you might not see exactly how this is stringed. So you see that this is the guitar, say guitar. This is called the body, just like my body. This is called the neck. All of this is called neck, just like my neck. And this is called the head, just like my head. These are called the tuning pegs. And these are called the frets. And these are called the strings. You see how many strings are there? 1, 2, 3, 4, 5, 6. So there are 6 strings. And these strings, you have to combine them, and then that you have to make sure that you push some strings down to produce a melody or a harmony. So for instance, it means that I'll be sweeping on my right hands. I have some we call it a musical picks, we call it the picks, or we call it the plectrum, right? So this is a very interesting demonstration. So just write a demonstration for the oscillatory motion. Because you know that you've been watching music at church, you're using music in televisions, you see, in YouTube's, in online, in WhatsApp. So then you didn't even think that those devices, musical instruments that are used to produce such kind of the music are actually describing oscillatory motions. And you as an ordinary diploma, ordinary secondary school students, you should have the ABC about it. So okay, so this I'm going to produce now. I'm going to sweep it down up. So if it is sweep downs, these strings are going to vibrate. They are going to describe to and fro motion. And when they are going to describe to and fro motion, then they have their resting position. Right now, these strings are all the 6 strings of the guitar are in resting position, right? So because they're in resting positions, we call this they are at their equilibrium positions or at their main position. Because you say that a simple oscillatory motion is a type of the motions in which a body moves to and fro about its main position. So now there is no any oscillatory motions. So these strings are at rest. So even if that I'm going to pluck them, okay, or to strum them by using these right hands, then after time they will be stopping, they'll be completing the oscillatory motions. So it means that they'll be moving to and fro, passing through the main position. So let me just push some of the strings and then produce a, so you see, I've swept it down. So this is oscillatory motions. 1, 2, 3, 4, 5, 6, 7. See, then I can also sweep up from up. This is called the up stroke. So you see, the same music, right? So that is oscillatory motions. But now if you want to make a music, you know that we combine this down stroke and the up stroke. Yes, but with a very specific phenomenon called time signature. But don't worry about that. So it is strumming down up. So it means that this strings will be describing simple harmonic motions or periodic motion, or we call it oscillatory motion. So let us go now. So it means that so you see that these strings are vibrating, right? So it means that you have to, for example, that if you want to produce a slow music, motions or periodic motions or vibration motions. We're going to cover also this guitar or even the music about overtones, about the first tone, second, about the tones, semitones in wave, which is the topic of the Form 4. So I believe you enjoyed this, so you can even have a guitar, we can ask for the guitar, and then try to produce this music and think in your mind that this is oscillatory motion. So it means that you can make some of the devices which describe oscillatory motion. So the Form 2 knowledge at least that give you something about the motion. So thank you very much. So let us continue with the next part with other examples of other examples of motion, of oscillatory motion, right? So let us continue with our session. So the third example, is I want to mention first of the examples which are familiar, right? Is a swing, or in Swahili we call it bembea, right? So a swing or bembea, right? Bembea, okay, when a push force, so you know this one, you have been using it during your childhood. When a push force is applied, the push force is applied, right? Is applied to the swing. At equilibrium. Okay. Then it oscillates, creating equilibrium or resting position. Then it oscillates. To and fro. To and fro motion. So a swing is another example of simple harmonic or periodic motion or oscillatory motion. When a push force is applied to the swing at equilibrium or rest, then it oscillates to and fro motion. So for instance, that this is the resting positions of the swing, then you know that actually I can come back and then I can generate a push, then moving this way, right? Moving this way. So this is oscillatory motion. Physics is beautiful. This is oscillatory motion. So to and fro. And then later on it will stop here, right? Interesting. So I would like just to take you into the first example of these oscillatory motions. I believe that you enjoyed the beauty of physics, and with the aid of demonstrations, I believe that now your love in physics is well restored, and that is my intention. So I would like to see that you enjoy it for the rest of your life, and then you find that the stuff for physics becoming easy, right? So we had a very interesting demonstration. Now let us continue with the theoretical. Then the first example, flapping of the wings. Flapping of the wings, we have birds in our daily life, okay? Flapping of the wings. We used to see birds that fly, right? Flying on the birds. We say that insects and birds, or birds and some of the insects, okay, fly by flapping. By flapping their wings. Flapping their wings repeatedly. the wings repeatedly and periodically. Periodically. Okay, periodically. Yes. So flapping of the wings. That's another example of simple harmonic. For example, suppose that you know that even after that you look like birds, but we have an image and the likeness of God, right? So because a bird has wings, the two hands of the birds are the wings, and hence it has what? Two legs, just like us, right? So it means that this is flapping of the wings. So when birds are flying, this is what is happening, right? Flapping of the wings. It means it can flap in this way, can flap in this way, can flap in this way, right? That's the flapping of the wings. So you see the simple harmonic 2. So you see 2 and 4, 2, 2 and 4, 2 and 4, 2 and 4, 2 and 4, 2 and 4. You see? So now it's getting higher and higher. That is of 40, flapping of 40 of the wings. Then the fifth example, we say that beating of heartbeats. We have hearts. Beating of heart. Very interesting. Even myself who is teaching you, I have a heart. And you who is watching this video, also you have a heart. The beating of 40 of heart. So when our hearts pumps, when our heart pumps blood, right? When our heart pumps blood, when our heart pumps the blood in and out, you know that when it is in, means we have arteries and also we have veins, right? Veins, they are taking the oxygenated blood from the different parts of the body, returning back to the heart. And there's artery, they take oxygenated blood from the heart into different parts and distribute it into all the parts of my body. How about yours? Tell me in the comment section. In and out, okay? In and out, it causes the heart muscles to move to and fro. This one, it causes the heart muscles to move to and fro, to and fro. Okay, to move to and fro. So the heart pumps the blood. T, 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 T. So pumps in, pumps out, pumps in, pumps out, pumps in. So that's a simple harmonic motion. Okay, the sixth example is oscillation. Say that so you say that oscillation of the liquid in the YouTube. So YouTube, it's not a YouTube for the video, about YouTube. It's can be a glass material or something which has this shape. If you fill the liquid and then you displace for a particular distance, then you find that this liquid begins to execute simple harmonic motion. So oscillations of the liquid in the YouTube. The seventh example, which may be advanced for you, is compound pendulum. I don't want to touch it because it's very advanced for the Form 2 students to understand the use of compound pendulum. Just to keep it as you are, we call it as it's. Just to keep it as you are remaining fools. When you reach the advanced level, you'll understand the meanings of 40 of compound pendulum. So that's the end of 40 types of motion. I told you 3 basic types of motion: translation motion, rotation motion, and oscillatory motion. Allow me now to take you into the next subtopic, which is distance and displacement. Okay? So ladies and gentlemen, right now, as I say that, the subtitle for this one is types of motion, and there's distance distance and displacement. Okay? So we have against another fundamental question, right? And this might be question 6 if I'm not mistaken. What is distance? What do you understand when you hear the word distance? Right? The term distance in simple ways you can define in 2 ways, right? For the 2 definitions, I found 2 definitions for distance. You say distance, first of all, these physical quantities, there are something called physical quantities you learn there's physical quantities, which you have 2 types of physical quantities, fundamental physical quantities and rare physical quantities. But those 2 types of physical quantities, we can also classify them as vector quantity and scalar quantity. So for instance, for example, distance, it's a scalar quantity, while displacement is a vector quantity. I will tell you the difference between scalar and vector quantity. So what is distance? So you say that distance, we say, is a scalar physical quantity. It's a scalar physical quantity. The scalar physical quantity. Okay, this is the scalar physical quantity. The scalar physical quantity, which possess only magnitude. Possess only magnitude of length. Magnitude of length, right? Between 2 points. Between 2 points. This is the first definitions of distance. Before I explain it, let me give you the second definition, so alternative definition. Distance is a total movement. So distance, the total movement of an object. Remember that the reference syllabus for this material is the syllabus and curriculums of United Republic of Tanzania. Movements of an object without any regard to direction. So he said that this is the total movement, right, of an object without any regards to the directions. We don't care about directions when we talk about distance, or we want to describe about distance, or when a body describes a distance. We don't care about direction, right? So you say that what is the distance? Is a scalar physical quantity which possesses only magnitude of length between 2 points, or is the total movements of an object without any regard to the directions. So this is the scalar physical quantity. Scalar physical quantity is a physical quantity which have only magnitude, while vector physical quantity is a quantity which have both magnitude and direction. When we say magnitude, we say, for example, the distance from Dar es Salaam to Dodoma, we say that maybe it's more than 400 kilometers. So 400 kilometers, it's a magnitude. But again, if you want to talk in terms of displacement, they say the distance from Dar es Salaam to Dodoma is more than 400 kilometers, and Dodoma is western of 40 Dar es Salaam, so included the direction. So simply this possesses only the magnitude of the physical quantity, and that's magnitude of length, not of any length between 2 points. So in terms of distance, we need to have 2 points. Even displacements also we need to have 2 points, right? In order to verify or to identify the magnitude. So the geometrical representation of this phenomenon suppose that we have 2 points. The first point is A, and the second point is B. Right? So say the distance between point A and B, this one, we say it is 20 meters. So that's what we call the distance between point A and B. We didn't care about direction. So that means of distance. So you have to understand that the great difference between distance and displacement, speed and velocity. Acceleration, okay. Acceleration, okay, there's no difference. So this is geometrical representations of that sentence. Again, we have some examples of distance. Before even mention about just a unit as a unit, examples of distance. The first example, for example, the distance from Dar es Salaam to Mount Kilimanjaro. Distance from Dar es Salaam to Mountain Kilimanjaro. Mountain Kilimanjaro is 462 kilometers. Distance from Dar es Salaam to Mountain Kilimanjaro is 462 kilometers. That's the example of distance. The second example of distance is this one. Distance from Dar es Salaam or from Zanzibar to Dar es Salaam, the business capital city of Tanzania. Dar es Salaam is 158.5 kilometers. Okay, so those are the two examples. You can have even more than those two examples, but those are the two examples of distance. I didn't say anything about direction, but where is Zanzibar from Dar es Salaam? Or where is Dar es Salaam from Zanzibar? I didn't talk also where is Dodoma from Dar es Salaam? Where is Dar es Salaam from Dodoma? So whenever you hear those physical quantities or magnitudes in length, that means it's distance, it's not displacement. Then now let us go to the very important terminology, which is a unity of distance. So both distance and the displacement have the same SI unit, right? So you say that the SI unit, SI unit of distance, the SI unit of distance is meter. So unit of distance is what? Meter. The SI unit of distance is meter. Okay, and the center 40 of distance. Small letter t. Meter or some of the, this is meter, and also some of the countries, we call it this one. But also distance has other units, right? Other units of 40 of distance are, we have centimeter, we have millimeter, we have kilometer, we have decimeter, we have millimeters already, we mentioned, we have diameter, we have hectometer. Okay, so how many are there? 1, 2, 3, 4, 5, 6. Okay, hectometer. And also you have miles. We have miles, right? We have miles, we have feet, we have inches, etc., etc. So those are the other units of 40 of distance. If you have any question about distance, you can ask in the comment section. But allow me now to take you to the second phenomena that's called the displacement. If you enjoy the beauty of physics, displacement. Displacement. Say displacement. Say displacement. Displacement. Very interesting phenomena in physics and engineering. So you have a fundamental question. What is displacement? That's a very important question. What is displacement in physics? What is displacement in physics? You can pause this video and ask yourself this question. What's displacement in physics? Write down. Write down the meaning of displacement in physics. So it's a displacement in physics, we say that is a vector quantity, not a scalar quantity anymore. A vector quantity which possess both, so possess both magnitude and the direction. Magnitude and direction. Which possess both magnitude and the direction of lengths between two points. Of lengths between two points. Lengths between two points. So we say that displacement in physics is the vector quantity which possesses both magnitude and direction of the lengths between two points. So this is the vector quantity which possesses both magnitude and directions of lengths between two points, because they measure magnitude and directions of velocity or speed. That's why that we clarify. So magnitude means that the size, right, of that physical quantity, of that distance between the 2 points. Then directions means that where the direction is. So geometrical representation, suppose that we have point A and also we have point B. So this is point A and this is point B. Then you have direction like this. So it means that then here we have direction. So this arrow indicating direction. And then here we have a distance between these 2 points. This distance, let's say it is 20 meters. So direction, suppose that this is west, this point will be east. So that the meaning of what? Meaning of displacement. So it's a vector quantity which has both magnitude of 20 meters for distance between point A and point B, and also tells the directions. That the direction of the motion is from point A to B. While in displacement, directions may be from A to B or B to A. But this point, directions of these motions, if it's a car, if it's a person, from A to B. But also you can split the directions of B with respect to what? To F. But now I'm in the western of a particular place. For example, that the restaurant is western of Zanzibar. So let us see some real-life examples of displacement. Okay? Examples of displacement. So we like just to use the same examples, like in distance. The first one, distance from the restaurant to Mountain Kilimanjaro is 462 kilometers. So then we say in terms of displacement now, we still say that the displacement of mountain Kilimanjaro the displacement of these abbreviations of our mountain Kilimanjaro mountain Kilimanjaro from Dar es Salaam. From Dar es Salaam is 462 kilometers, but in northern direction. Northern direction, or northern of Dar es Salaam. So Mountain Kilimanjaro is north of Dar es Salaam at the minute. So 462 kilometers, that's the magnitude of length. Then northern directions, or north of Dar es Salaam, or northern directions means the direction. Again, you have a distance from, so I say the displacement the displacement of Zanzibar from Dar es Salaam is 158.5 kilometers. But its directions is what? Eastern direction. Eastern direction. So this is how we write problems of displacement. There are different ways of writing. You can mention instance or whatever. When we'll be learning the topic called the sphere in basic mathematics for the form series, you will see the importance of directions. Right now you can say, I know direction. Okay. The SI unit of displacement, the SI unit of displacement is what? Is meter. So they have the same, it means that it's simply said that displacement, distance, and the displacements have the same units. So displacements also can be measured in millimeter, in miles, in feet, in inches, in decimeter, in kilometer, etc. So now this is the end of this session 3. I'd like to leave homework for you. And this is very interesting questions which will prepare you for the next session. What is the difference between speed? What is the difference between speed and the velocity? Give 3 differences. And the velocity. Give 3 at least more than 3, means at least 3 differences between them. That is, if you do that question, you'll have good preparation of the next session, that's session 4, which is all about the speed and the velocity. So this is the end of the session. I really thank my Father who is in heaven, who have been with me during the preparations of this session and give me energy, encouragements, techniques, methodologies of teaching you all about motion in straight line and different types of motions, displacement and distance. So I give him all the glory because he's the ones that working in me. I thank you also for taking your time I invite you to join me in the next session, that's session 04. In case you have any questions about session 00, General Introductions of Physics Form 2, session 01, General Introductions of Motion in Straight Line, session 2, which is types of motions, session 3, types of motion, distance and displacement. Ask me in the comment section, and then submit your homeworks in the comment section, and also rate the questions which have been asked by other students worldwide in the comment section, and then establish even your comment means that establish your group discussions online. And you have to make sure that you subscribe, so once that we record and process and upload the new video of session 4, which will be titled as Speed and Velocity, then the YouTube community will give you special notification. So be learning. The next sessions I'll be teaching you speed and velocity, and if the times will allow us, also I'll teach about the speed, or we got distance time graph, or displacement time graph. Very interesting point. So may God bless you, and may God keep you until we meet in the next session. I'm always praying for all my online students and even my physical students. So even yourself as a student, make sure that you include me as your teacher in your prayer, so that God may give me energy and encouragement and wisdom and knowledge, understanding, skills to do this business until I finish it before I leave this planet Earth. May God bless you. Make sure that you have to think differently, and every time that I'll be teaching you, think how you can take this knowledge that I'll be teaching you, which is classroom, and say, we call it legal instructions, which you have to get, and combine the knowledge and wisdoms of Word of God, and in order to solve real life problems. So I want to give you a challenge. Once, every time that you are learning this material, ask yourself, what problem can I solve? Where can I use these information to help me in my daily life? Okay? So may God bless you. See you in the next session.